All right, so you should be able to convert unit to units now. So grams to moles, moles to particles, and go back particles, moles to grams. All right. We talked about in the previous two videos that we can convert back and forth between moles and particles. Now from moles you can go anywhere. Now from moles you can go to particle, moles you can go to grams. Let's say you have a mole. How do you convert that to gram? What is the relationship between mole and gram? The molecular weight or molar mass. Okay, so if you have a mole, I'm going to time this number with grams per mole. Put moles at the bottom. So moles and this mole will cancel out. Now, what's the relationship between mole and grams? The molecular weight. Okay, molar mass. The mass in gram of one mole by definition. All right. Let's say you have a gram. Let's say 5 grams of iron, 10 grams of sodium. How do you convert that back to mole? All right, so you have grams, go back to mole. Well, we have grams. I'm going to time a term that have grams at the bottom, moles at the top. So gram will cancel out. Now, what's the relationship between moles and gram? Same thing, molecular weight, molar mass, right? So molar mass, that's the mass of one mole. Okay. All right, I'll do the first one for you. Okay. All right. A helium balloon sold at the amusement park contains 0.462 mole of helium. All right, so we have moles of helium here. How many grams of helium are in the balloon? Well, convert moles to gram. All right, so all right, we want grams, so we want to find grams of helium. What we got 0.462 moles. Okay, so convert grams to moles. So I'm going to time moles at the bottom. These two would cancel out, and grams at the top. Okay. All right. 1 mole of helium. How many grams of helium is in 1 mole of helium? Look at the periodic table. The molar mass, the molecular weight of helium is 4. So 1 mole is 4 grams. All right. So mole cancel with moles. Do the math here. You should get that number. Okay. Don't forget to make it an appropriate sig fig. So 3 sig figs. 1, 2, 3. So make it 3 sig fig 1.84. So 8, round them up. Here we go. All right. All right. This one, your turn. Okay. So grams to mole. Pause the video and then check with me. How many moles of water? All right. So we want to find mole in 10 grams of water. Okay. 10 grams of water. So 10 grams, go back to mole. Basically, you just time a term that has grams at the bottom, moles at the top. So grams will cancel out. All right. All right. So let's do it. So we want to know moles of water. So I put right here. What we have 10 grams of water. I'm going to times it with something that has grams at the bottom, moles at the top. And we know that 1 mole is how many grams of water? Well, we have to look at the periodic table, right? So 2 hydrogen, 1 oxygen. 1 mole of water contains 1 oxygen, 2 hydrogen. Okay, 1 mole of oxygen weight 16, a mole of hydrogen weight 1.01, but there are 2 moles, so 2.02. So 16 plus 2.02, that's 18.02. Gram cancel out, and then you're going to get that number. Okay, now 4 sig figs, so 1, 2, 3, 4, 3 right here, round them down. Here we go. All right, if you can make it as a scientific notation, if I ask you for it, ta-da, that's it. Okay, all right, one more time. This one I'm going quick. So a sample contains 2.98 grams of titanium. So we have a sample of titanium contains 2.98 grams of titanium. How many titanium atoms are present in this sample? Titanium is usually used in your phone case. Okay. All right. So so we have grams. We want to find atoms of titanium. So we have to go from grams to mole and moles to atom. All right, so 2 steps here. All right, we want grams, we want atoms. So put atoms right here, atom of titanium. The unit that we have grams of titanium. All right, grams to mole first. So I'm going to put grams at the bottom, moles at the top. Look at the periodic table. 1 mole of titanium is 47.87 grams of titanium. There we go. All right, so gram cancel out. All right, so we get to mole now. So next one, mole to atom. So I'm going to time the term that have moles at the bottom. So mole will cancel out. The top is atom of titanium. So 1 mole of titanium is how many atoms? Avogadro's number 6.02 times 10 to the third atoms. Now, don't forget that. Don't forget that. So mole of titanium cancel out. Do the math right here. So watch out. There are quite a lot of numbers. So 2.98 times 6.02 times 10 to the 23rd divided by 47.87. You should get the long right there. This is from my calculator. No, I'm going to keep the whole thing there. And then round them up or round down. So 3 sig figs. So 3 sig figs, round them up to 4. To 5, 3.75 times 10 22nd atom titanium. Okay. All right, and we have one more. All right, find the mass of 3.21 times 10 21st methane molecules. The mass, well, mass that's in grams. All right. So we want to get grams. Start with molecules. All right. So molecules. How to get to gram? You can't go directly to gram, but I know that I can convert molecules to moles, and then moles to grams, right? All right, so we want grams of methane. What we have 3.21 times 10 21st methane molecules. So we start with that molecules. All right, molecules to mole first. So I'm going to put molecules at the bottom, moles at the top. What's the relationship between mole and molecule? 1 mole equal to, again, Avogadro's number, 6.02 times 10 23rd molecules, so they cancel out. Okay? All right, we got 2 moles now. So moles to grams. So basically using molar mass here. Put moles at the bottom, grams at the top. 1 mole methane is equal to how many grams? So we have 1 carbon, it's about 12.01. Hydrogen is 1.01 each. There are 4 of them, so 4.04. Plus 12.01, you get 16.05. Oh, I remember that. Oh, okay, I'm so cool. Moles cancel out. Do the math here, you should get that number. So 3 sig figs, 3 sig figs. Draw them up. Okay. All right, so practice makes perfect. So class activity number 3, super simple there. So convert from grams to mole, moles to gram, or to particles. Okay.